3.5 Conditional statements and their converse. A conditional statement is an if-then statement. Example, if it is Monday, then it is a school day. A hypothesis is an assumption. So in the above example, it's Monday is the assumption. The conclusion is the result of a hypothesis. In the above example, it is a school day is the conclusion. A counterexample is an example that disproves a statement. So in the example, if it is Monday, then it is a school day, a counterexample would be a Monday in July, where there is no school. If P then Q is notation for if P then Q. It's read as P implies Q. A converse is a conditional statement in which the hypothesis and the conclusion are switched. In the example, if it is Monday, then it is a school day, the converse would be if it is a school day, then it is Monday. A biconditional statement is a conditional statement whose converse is also true. It is written as P if and only if Q, and noted as P if and only if Q. An example would be if a number is even, then it is divisible by 2. The converse of that is also true. The converse would be if a number is divisible by 2, then it is even. So that statement is biconditional. Here's an example. A person who cannot distinguish between certain colors is colorblind. Write this sentence as a conditional statement. So, if a person cannot distinguish between certain colors, then that person is colorblind. Write the converse of the statement. The converse, we flip P and Q, so then a person is colorblind. If a person is colorblind, then that person cannot distinguish between certain colors. So the converse is if a person is colorblind, then that person cannot distinguish between colors. So I just flipped my hypothesis and my conclusion. Is your statement biconditional? Well, let's see. If a person cannot distinguish between certain colors, then that person is colorblind. That's true. And if a person is colorblind, then that person cannot distinguish between certain colors. Well, that's true too. So yes, it is biconditional. Another example, verifying a statement using truth tables. A coach made a conditional statement. If it is raining outside, then we practice indoors. Let's look at when this is true. So the hypothesis is P, it's raining outside, and the conclusion is Q, we practice outdoors. Let's look at case 1. So case 1, the hypothesis is true and the conclusion is true. The result is that P does imply Q. The coach kept his promise, so the coach's conditional statement is true. It rains outside, and we practice indoors. So that whole thing is true. A second case is that the hypothesis is false, and the conclusion is false. That actually results in a true conditional statement, because it does not rain outside, and we practice outdoors. Well, that's true. So when the hypothesis and conclusion are both false, a conditional statement is true. Case 3, the hypothesis is false and the conclusion is true. It does not rain outside and we practice indoors. The hypothesis is false. The conclusion is true. So the conditional statement is true. And a fourth case. the hypothesis is true and the conclusion is false. It rains outside and we practice outdoors. When the hypothesis is true and the condition is false, that results in a false conditional statement. So in summary, a conditional statement consists of a hypothesis P and a conclusion Q. The different ways to write a conditional statement include the following: if P, then Q, P implies Q, or P implies Q with the fancy arrow. To write the converse of a conditional statement, switch the hypothesis and the conclusion. Some things you need to know. A conditional statement is either true or false. A truth table for a conditional statement can be set up as follows. A conditional statement is false only when the hypothesis is true and the conclusion is false. Otherwise, the conditional statement is true, even if the hypothesis is false. You can represent a conditional statement using a Venn diagram, with the inner oval representing the hypothesis and the outer oval representing the conclusion. The statement P implies Q means that P is a subset of Q. Only one counterexample is needed to show that a conditional statement is false. If a conditional statement and its converse are both true, you can combine them to create a biconditional statement using the phrase if and only if.